Hey guys, it's Ms. Johnson here, and I'm here to bring you our 6-3 notes on dividing polynomials. Up at the top of your notes sheet, the first example says Ariana needed 140x squared plus 60x square inches of paper to make a book jacket 10x inches tall. In figuring the area she allowed for the front flap and the back flap. If the spine of the book jacket is 2x inches and the front and the back of the book jacket are 6x inches, how wide are the front and the back flaps? So basically, we know that area is equal to length times width. Okay. We also know that the area is 140x squared plus 60x. We know that the length, or the width, I guess I could say in this case, is 10x inches long, and we know that all of this is equal to the length. Okay, so what I need to do is I need to take the area and I need to divide it by the width so that I can get the length left over. So my area is 140x squared plus 60x, and I'm going to divide out the width. Because if I divide out the width, I'll get the length that's left over, and then that can lead me to these flaps that I'm trying to find. So when we divide a polynomial by a monomial, I'm going to split this off into two fractions because both things are being divided by the 10x. So I have 140x squared divided by 10x. I also have 60x divided by 10x. Now when I simplify those two, 140x squared divided by 10x is 14x, and 60x divided by 10x is 6. So I know that my length is equal to that. Well, the 14x comes from right here. 6 plus 2 plus 6 is equal to 14x. So that's taken care of. That must mean that this piece is for the two flaps. Okay, so if I know that there's two flaps equaling 6, I can divide by 2, and I know that each flap is equal to 3. So I'm looking at 3 inches for each of the flaps. Okay, so I had to divide my two polynomials in order to figure out what that would look like. Now, when we divide a polynomial by a monomial, this is what we do. We take each term in the polynomial in the numerator and divide it by the monomial. Remember that you can pause the video at any point if you need to take some extra time to write things down. So let's take a look at number 1. In number 1, I have 4x to the third plus 8x minus 12x squared, and I'm going to divide that all by 4x. So I'm going to split each term into a separate fraction. So I have 4x to the third divided by 4x. Then I have 8x divided by 4x. Then I have 12x squared, or I should say negative 12x squared divided by 4x. And simplify each one of those individually. So 4x to the third divided by 4x. The 4's are going to cancel out. X to the third over x is x squared. So I just have x squared there. 8x divided by 4x, 8 divided by 4 is 2. X and x cancels out, so I just have a 2 there. And then 12x squared divided by 4x, 12 divided by 4 is 3, and x squared divided by x is just going to be x. So it's minus 3x there. Now writing this in standard form, because we know we're supposed to decrease our exponents, it would look like x squared minus 3x plus 2. Let's go ahead and try number 2 together. In number 2, I have 16ab, a to the 5th, b to the 3rd, plus 12a to the 3rd, b to the 4th, minus 20a, b to the 5th, all over 4a, b to the 4th. So two variables here now, two variables that I'm looking at. I'm going to go ahead and get this out of my way so I have some extra space. All right, and let's go ahead and well, we'll just do this, slide it down. Split this off into my 3 different fractions here. So I'm going to have the first one, 16a to the 5th, b to the 3rd, all over 4a, b to the 3rd. My second one, 12a to the 3rd, b to the 4th, over 4a, b to the 3rd. My third one, minus 20a, b to the 5th, over 4a, b to the 3rd. And now again, I just want to simplify each one individually. So start with the first one on the left. 16 divided by 4 is 4. A to the 5th over A, that's going to cancel out. That's going to be A to the 4th. B to the 3rd over B to the 3rd is going to cancel out. So I have 4A to the 4th there. In the middle one, 12 divided by 4, I can take out a common factor of 4, that's 3. A to the 3rd over A, that's going to be A squared, that one's going to go away. And B to the 4th over B to the 3rd, all three B's are going to cancel, and I'm going to be left with just B up on the top. And then the last one, 20 divided by 4 is 5. That goes away. A over A goes away. B to the 5th over B to the 3rd is going to leave me with B squared. So I have 3A squared B in the middle. And then I have negative 5B squared at the end. So I have 4A to the 4th plus 3A squared B minus 5B squared. And that's my quotient for those polynomials. I want you to go ahead and pause the video at this point and see if you can solve number 3 on your own. And let's go ahead and look at our next examples. Now, when we are dividing a polynomial by a binomial, there's two ways that we can do this, okay? One way is using long division, and another way is using synthetic division. And I'm just going to show you a brief example of each. So let's start with the long division example. I have z squared plus 2z minus 24, and I'm literally going to set this up as long division, just like we did a long time ago in, 3rd grade, 4th grade, whenever we learned how to do long division. So the first number goes inside the box, like I have here, and the second number, or in this case the binomial, is going to go outside the box. So I have z minus 4 on the outside. Now you want to ask yourself, how do you make z look like z squared? What do you have to multiply so that z looks like z to the 2nd power? Well, I would need to take z and multiply it by another z. So since I need a z, it's going to go above my z term here. Okay, and then I multiply, just like we do in regular long division. I would take z times z, right there, which is z squared, so it goes underneath my squared term. I also take z times negative 4. It's like distribution. So z times negative 4 is negative 4z. Then at this point, I would subtract, just like we do in regular long division. So I'm going to subtract what I have. Z squared minus z squared cancels out. On the second one, 2 minus negative 4, this becomes adding a positive. 2 plus 4 is 6z. So I'm done with that first round. Now I'm ready to look at the second part. I need to bring down the negative 24. Again, just like in regular long division, we would bring the next number down. And then I do it again. What do I need to multiply z by to look like 6z? Well, I need a 6, because 6 times z is going to give me 6z. So if I multiply by positive 6, that means I'm adding 6 up here. And then I do the multiplication. 6 times z is 6z. 6 times negative 4 is negative 24. It looks pretty good because they're lined up with each other. 6z over 6z, negative 24 over negative 24. If I subtract those, 6z minus 6z goes away and I'm left with 0. Negative 24 minus negative 24, again, that's adding a positive. So negative 24 plus 24 is actually going to give me 0. So I have no remainder left over here, and my quotient is simply z plus 6. So it's a little bit more than just dividing numbers, but it's still the same process. It's the same type of long division that we've always used. Now, synthetic division looks a little different. With synthetic division, I'm only concerned about the coefficients. So the 5, negative 13, 10, negative 8. And as long as my polynomial is in standard form, which it is here, then I'm not going to worry about the variables right now. I'm just going to worry about the coefficients. The first thing I need to find in synthetic division is take the x minus 2, set it equal to 0, and find out what x would equal. X would equal 2 in this case. So I'm going to take a positive 2 and I'm going to put it outside in a box here. That was just supposed to be a line. The pen kind of dragged a little bit. So I have positive 2 outside in this box. Then I'm going to list out those coefficients that I found. I have a 5, I have a negative 13, I have a 10, and I have a negative 8. You need to leave yourself enough space so that you can write one number and then draw a line underneath. So I've got a little bit of space to write one number, and I'm going to draw a line. And then I'm also going to make a vertical line to tell myself that this is the remainder at the end. Okay, so that's going to be my remainder, if there is any. Now here's how synthetic division works. The first number, the first coefficient, the 5, always drops down, and it just stays a 5. So my first number is going to be a 5. Now I'm going to multiply and add, multiply and add, multiply and add. I take my number outside, multiply it by the 5, and put my product up here. So 2 times 5 is 10. It goes underneath the negative 13. And then I add those together. Negative 13 plus 10 is negative 3. I take the 2 times the negative 3, which is negative 6. It goes under my next one. 10 and negative 6, 10 plus negative 6 gives me 4. And then I take the last one, 2 times 4, which is 8. Negative 8 plus 8 is 0. So my last number is 0. And then I work backwards to write out my answer, because these don't really mean anything until I put them in the form of a polynomial. So in this case, the last number is always the remainder, which is what that line reminds us of. The next number in, then I just work backwards. The next number in is the constant. The next number after that is my x term, and the next number after that is my x squared term. So I have 5x squared minus 3x plus 4 with no remainder. So that is my quotient. So two different types of division for polynomials. One is long division, one is synthetic, and we're going to do lots of examples of both. That's going to conclude our video tonight. Don't forget to go back to Schoology and take your quiz, and thanks for watching.